So we just found the derivative of a function using the regular definition of the derivative, which is f prime of x rather, is the limit as h approaches 0 of our difference quotient there, f of x plus h minus f of x all over h. That's assuming that the limit exists. I want to show you real quick an alternate definition of the derivative, okay, which you also have in your notes right there. We see f prime of a, so now we're looking at the derivative at a specific value of x. F prime of a is the limit as x approaches a of f of x minus f of a over x minus a. So it's another limit which is going to turn into the indeterminate form, 0 over 0, and we're going to need to simplify that. So let's take a look at a specific example, what you have there, example number 2. All right, we're going to look at the function 2x squared. We're going to derive it two different ways. We're going to derive it using the original definition, and then we're going to derive it using the alternate definition. So if we go with the original definition, right, you see here f of x is 2x squared. So f prime is going to be the limit as h approaches 0, and then we have our function with x plus h plugged in, minus the original function all over h. So this is a 0 over 0 limit. We need to simplify that numerator. So you can use your algebra skills. We're going to expand out x plus h squared, and you've done that before now. So we know that that's going to become x squared plus 2xh plus h squared, and then we have the 2 out front still. So we have the limit as h goes to 0. Our 2 is still hanging out front, and then we now have x squared plus 2xh plus h squared. Okay, and that's the expansion of the binomial x plus h squared. We still subtract, and then our 2x squared at the end. That's just hanging out in the numerator, and h is hanging out in the denominator. Okay, so what should we do next? If you said distribute, you're correct. We're going to distribute that too. So let's see if I can sneak all this into this little bit of space here. So we have the limit as h approaches 0, all right, and we're going to have 2x squared plus 4xh plus 2h squared. That's the 2 being distributed. And we still have the minus 2x squared at the end, all over h. So what should happen now if we did our math correctly? Exactly. The 2x squareds, the non-h terms, should go away. And they do. They wipe each other out. One's positive and one is negative, leaving us with 2 terms left in the numerator. And they both have an h, so we can factor that h out. So we now have the limit as h approaches 0, and we have h factored out of the numerator. 4xh divided by h is 4x. 2h squared divided by h is 2h. We still have that h in the denominator. What happens with the 2 h's? Exactly, they eliminate each other. They cross out. And now the all remaining h's go to 0. So this h we see is heading to 0, which means that's heading to 0. So we are left with just 4x. All right? So let me sneak a quick marker here. So what we know now is the derivative, f prime of x, is equal to just 4x. And we're interested in the derivative's value at 2. So f prime of 2, we're going to plug 2 in for x. So that's 4 times 2, which means we get an answer of 8. Now, if we do everything correctly over here, we should get the exact same answer using the alternate form of the derivative. So let's go ahead and do that. So we're taking the limit as x approaches 2 now. It's not h approaching 0 with the original definition, but the alternate definition, x approaching 2. So we have f of x minus f of 2. We're going to have to plug 2 into our original function. 2 squared is 4, and doubled is 8. So this is really an 8 right here. So we're going to have our function, which is, well, first of all, we need our limit still. Limit is x approaches 2. Our function is 2x squared minus our function's value at 2, which is 8, over x minus 2. If we plug in 2 for x right here, we get 8 minus 8 in the numerator, 2 minus 2 in the denominator. We get 0 over 0. So we know that we have the indeterminate form, and therefore we can simplify. So let's do that. How do we simplify this numerator? Well, if you said factor out a 2, that would be a good idea. So if we do pull out a 2, then we are looking at 2 times x squared minus 4 in the numerator. Whoops, I lost my limit. So we're just going to cross that out and move that right over there. And then x minus 2. We still can't cross out the x minus 2 yet, but we can still simplify that numerator even more so, right? X squared minus 4, isn't that dots, the difference of 2 squares? It's x minus 2 and x plus 2. So what do we have? We have the limit as x approaches 2. We've got this 2 right here, and then x plus 2 times x minus 2 all over x minus 2. What do we cross out? We can cross out the x minus 2's. And now what happens when we plug in 2 for x? We have 2 plus 2 or 4, doubled is 8. So we get 8 over here, just as we got 8 over there. Both definitions will work out. One is the official definition, one's the alternate definition. This is the one that we're going to see more often, but you want to be ready for both on the AP exam. What do we cross out? We can cross out the x minus 2's. And now what happens when we plug in 2 for x? We have 2 plus 2 or 4, doubled is 8. So we get 8 over here, just as we got 8 over there. Both definitions will work out. One is the official definition, one's the alternate definition. This is the one that we're going to see more often, but you want to be ready for both on the AP exam.